Good morning everyone. I am Arpita Jatta and today we will learn about COCOMO model. So let's get started with what actually COCOMO model is. So firstly COCOMO stands for the Constructive Cost Model, which is one of the most widely used software estimation model in the world. It was developed by Barry Baum in 1981. The COCOMO is a procedural software estimation model which is used to estimate effort and duration based on the cost of the software. COCOMO predicts the effort and schedule for a software product development based on inputs rating to the size of the software and a number of cost drivers that affect productivity. Now there are three stages of COCOMO. First basic, second intermediate and third detailed. Now let's briefly understand about these three stages. First basic model. This model would be applied early in a project's development. It will provide a rough estimate early on that should be refined later on with one of the other models. Second intermediate model. This model would be used after you have more detailed requirements for a project. Third one is detailed model. When design of the project is complete, you can apply this model to further refine your estimate. Now there are three modes of software development, which is considered as organic, embedded, semi-detached. In organic, this mode is used for relatively small software teams developing software in a highly familiar in-house environment. Second, embedded, operating within tight constraints where the product is strongly tied to a complex of hardware, software, regulation and operational procedures. Semi-detached, an intermediate stage somewhere in between organic and embedded. Projects are usually of moderate size of up to 3 lakh lines of code. The basic model. The basic COCOMO model estimates the software development effort using only lines of code. There are various equations in this model, which are effort applied, development time, people required. People required is equal to effort applied by development time, where KLOC is the estimated number of delivered line expressed in thousands of code per project. Now list of constraints based on mode for basic COCOMO. Suppose your or project type is organic. So there are four values A, B, C, D which are predefined. So you can use directly. If your project type is semi-detached, you can use these four values 3.0, 1.12, 2.5, 0.35. And if your project type is embedded, you can use the four values ABCD, which is 3.6, 1.20, 2.5, 0.32. Now intermediate model. This is an extension of basic COCOMO model. This estimation model makes use of set of cost driver set of attributes to compute the cost of software. The formula for effort calculation is E is equal to AI KLOC into BI into EAF, where E is the effort applied, KLOC is the kilo lines of code, and EAF is the factor calculated above. These cost drivers can be classified under project attributes, hardware attributes, product attributes, personal attributes. In product attributes, there are 3 points: size of applications database, complexity of product, Software's reliability extent. In hardware attributes, there are also 3 points: total turnaround time, memory constraints, runtime performance constant. In project attributes, there are two types: software tools used, required development schedules. In personal attributes, application experience, coding experience, software developers capability, analyst experience. Now this is the table which has coefficient and exponent. Coefficient as AI and exponent as BI. So if your project type is semi-detached, you can use 3.0 coefficient and exponent 1.12. If your project type is organic, you can use coefficient as 3.2 and exponent as 1.5. If your project type is embedded, then you can use coefficient as 2.8 and exponent as 1.12. Now the third detailed model. The detailed COCOMO incorporates all characteristics of the intermediate version with an assessment of the cost drivers impact on each step of the software engineering process. The detailed model uses different effort multipliers for each cost drivers attribute. In detailed COCOMO, the whole software is divided into different modules, and then we apply COCOMO in different modules to estimate effort and then sum of the effort. The effort is calculated as the function of program size, and a set of cost drivers are given accordingly to each phase of the software life cycle. Now there are 6 phases of detailed COCOMO. First, planning and requirement. Second, system structure. Third, complete structure. And fourth, module code and test. And fifth, integration and test. And sixth, cost constructive model. Example: a distributed management information system product for an organization having offices at several places across the country can have the following subcomponents: database part, graphical user interface, communication part. Of this, the communication part can be considered as embedded software, the database part could be semi-detached software, and the graphical user interface as organic software. The cost of these three components can be estimated separately and summed up to give the overall cost of the system. Now let's see what are the advantages of COCOMO model. So COCOMO provides a systematic way to estimate the cost and effort of a software project. COCOMO can be used to estimate the cost and effort of a software project at different stages of the development process. COCOMO can be used to evaluate the feasibility of a software project by estimating the cost and effort required to complete it. COCOMO helps in identifying the factors that have the greatest impact on the cost and effort of a software project. Disadvantages of COCOMO model. COCOMO assumes that the size of the software is the main factor that determines the cost and effort of a software project, which may not always be the case. COCOMO does not take into account the specific characteristics of the development team, which can have a significant impact on the cost and the effort of a software project. COCOMO does not provide a precise estimate of a cost and effort of a software project, as it is based on assumptions and averages.